looks like they did their holiday, winter break travels. And I hope that everyone came back is healthy, got a chance to get tested, is, doing their thing, able to see everybody that you might not have seen in a while. Give them all the hugs. And now we're back at it, making things again. And so this week we're on, I think this is week 15. I'm sure Ashley will correct me if I'm wrong in the title of the video on YouTube, but this week we're gonna make a change and go back to textiles in an interesting and sort of weird way that I hope that you find fascinating and curious, and makes you excited to get back into the sewing textiles area this week, or to hop in and see how you can integrate these skills in with some other things that we've been up to. So with that, let's go through CNC embroidery and e-textiles just to see what this is going to be. So we're going to focus on two things, and the first is going to be CNC embroidery, and that's admittedly fairly short because it's one machine. There's fantastic instructions, and we'll just sort of go over what it is and how it works. Then we're going to talk about e-textiles, and this is going to be sort of an explanation of what we're doing for sure, but then it's also going to be a primer for where we're headed, not immediately next, but in the not super distant future. We're going to talk a little bit more about circuits, or we'll more frequently talk about circuits. And so this gives us a chance to sort of re-explore those old ideas, and then to think about how you'd apply them in a nice, deliberate way. And also by the end, we're going to have gift bags for everybody. I know that we're not physically together right now, but we'll have them ready for you in the space for when you cycle back through, probably ready to pick up by tomorrow. So for this, let's get started with CNC embroidery. And so CNC embroidery is where we're headed. And mostly for us, that's going to mean ink stitch. And so there's this fantastic software. Embroidery is something that is really a big part of life. And I'm going to quickly stop my share. But here is like a embroidered hat that I wear regularly. That's from the old high school where I taught. And so it's got embroidery for Nike on the back, the Wildcat logo on the front. And all of that is done on an embroidery machine. And so from there, you can embroider all sorts of things. And it's neat when it's something that you bought, but it's even cooler if it's something that you've made. And so InkStitch is a software package that you can integrate in with Inkscape. And then you can use Inkscape and its vector design software to design in your own designs for a CNC embroidery machine. We have a small CNC embroidery machine. I was just informed a few moments ago by famous Kate at the Sevick House, and that we're getting a new one at MakeHaven, that they're working on getting a new, bigger one with multiple colors and lots of those sorts of details. The one that we have now will take ink stitch info, and it will be able to control your CNC, the embroidery machine. And so it looks like this logo here is InkStitch's own advertisement for their setup. It's just an extension to Inkscape, and you draw these crazy lines that are over here on the top left logo, where there's the little cross hatchings that sort of describe how you want it to stitch. Then it will simulate what that stitch will look like, and then it will fill it in and stitch it for you on the CNC embroidery machine. You can do this in a simulated view, and it feels like this might look intimidating and technical at the first glance, but the tutorial series for this is fantastic. Here is their tutorial series. And as we scroll through here, there's an introduction that walks you through. There's installation for how you put it in with like timestamps and all of it. How do you do it on a Mac? What does it look like for Windows? How do you customize the thing, add on shortcut keys? How do you do like different stroke types, the whole bit? The amount of detail that's put into this set of tutorials is breathtaking. They even go over like, how do you make it sort of break in the ways you want it to? How do you do zigzags? How do you do lettering? All sorts of different commands that you might have to go along with it. If you've ever wanted to have your own customized embroidered items, it is a whole host of things that you need to learn, but it's super useful and it works really well with any machine. We have our machine at MakeHaven. There's another one at the library across the green. from MakeHaven, and then we're going to get another machine with multiple colors is what we've heard. So it's super exciting to think about this. This is an 8-video series intro just for beginners, and then they have way more content for color blending and all sorts of stuff, where they've got tutorials that just like come out of nowhere. They go all, here's the applique, color blending, the Inkscape logo, fonts, there's tons and tons and tons of detail in their instructions. And so you can go all through this to really make sense of how you want your ink stitch experience to go. So there's tons of cool opportunities to learn how to CNC embroider. I want to be very clear. I've not run this machine extensively. I've gotten the badge a year and a half ago. It was one of my very first badges. I have crashed to the machine successfully. I've done a little bit of designing, but not much. So I don't want to give an impression that I would be an expert here, but I could help figure out some of the technical details we could work through. I know how I did break it, or it didn't, how it didn't work. And so I can help move forward. But Inkstitch does a really good job of making patches. So you can make patches like shown here on the right. You can directly embroider like this Rick up here in the top center. This skull thing is like someone custom designed that and then used an embroidery machine to make it. And then down here, this is what we're looking at. For embroidery machines, it's a little different than a sewing machine. Sewing machines, you can just sort of pass loose fabric through, but because the embroidery machine needs to move the fabric and the needle together, you really need to use sort of an embroidery hoop on the machine. And so you have to hold your fabric taut in an embroidery sort of hoop that goes along like this, that's attached to the machine. Our particular setup, that is limited to, I'm going to go with 5 inches across, 5 or 6 inches across. It's not very big. And hopefully the one that we're getting will be a little larger, but that sort of sizing and spacing is what we're looking for. They do sell hat attachments for the one that we have. And I've seen them before. I've looked them up, but I don't know why I didn't buy one. But I think that they're like $15 to buy a hat attachment if it works. So we can definitely look into that if somebody's interested and they really want to make their own hat, which I will split the cost of that embroidery hoop with you for sure. I would love to have a MakeHaven hat. But this is a neat sort of process that you can use to make really custom garments that can look completely professional and customized, and all of this you can design on your own. But it is, I want to say, it is a fairly technical pursuit in that you're going to need to learn how to work with Inkscape to design that. But I would say it's not any harder than trying to learn the basics of 3D design in Fusion 360. It's a series of technical drawing skills that will fit together to make this happen. So it's very exciting. I hope that somebody goes after this. It's a really cool payoff. But the real heart of what I want everybody to do today, and the gift bag that we've gotten for everybody, is all about e-textiles. And so for us, what we're going to be focusing on is how do you take textile work, whether it's clothing that you have, garments, bags, wearables, whatever, and how do you add a little bit of blinkiness to it? How do you make them glow? And so our goal is going to be to go through these and try and make sense of it. But first, as a science teacher, there's some part of me that feels obligated for us to just review some of the words that we all probably learned, but probably also forgot. Not everybody needs to know all these words all the time, but we're just going to say them out loud because we're going to talk about circuits a fair amount over the next couple of months. And I just want to say these out loud so that we can all remember them and remember the details that go along with it. So also, fun fact, there's a lot of things going on that learning definitely happens over a lifetime. And just because it was said to you and you learned it and took a test when you were a high schooler has no bearing on the fact that you might remember it 20 years later, right? There's no reasonable way to think that you're going to remember it from back then. And that is even assuming it was taught to you well, which is not always a given. I know lots of science teachers that are medium on their understanding of electricity. So, here we go. These are the 5 words that I think are important enough for us to take a look at. Charge, which is just a property of matter, which is kind of cool. Current, which is a charge flow rate. Volts, which is in my mind at this point is just energy. Volts are energy. Power is about energy consumption, how much that energy gets used up. And then resistance is like friction, sort of like rubbing your hands together, that sort of old science trick. So we're going to go through each one of these 5 things with just a slightly more in-depth investigation, not trying to totally knock it out of the park. We're not going to ask you to do any math. There will not be a quiz at the end of this. Just want to say these words and get a chance for these juices to get flowing again. So first up, let's talk about charge. Inside of an atom, this is kind of what an atom looks like. Not exactly what an atom looks like. There's a nucleus in the middle with protons and neutrons. And then electrons live on the outside in this ring or clouds outside of the nucleus of the atom. And one of the things that's just a property of matter is sometimes it has mass and sometimes it has charge. Of the 3 particles that are in an atom, all 3 of them have mass. The protons and neutrons are pretty heavy and they live in the middle. The electrons are really light comparatively. And 2 of the 3 have a charge. The protons are positive and the electrons are negative. We don't know why particles have charge other than like quantum field fluctuations. But like, why they have charge is an interesting question. It's just a property of things and that's it. It's really important. It's fascinating. But for us, what we're going to be doing with it is not exploring sort of the existential end, but just looking at how you can use this. And so knowing that electrons that are sort of the outside bit of an atom, those are the ones that can get plucked off and carried along on a wire. They have a charge that becomes super useful. So we can track that charge. If we make those electrons flow through a wire, we call that current. And so that's the flow of charge. It's in German, I think, but it's delta Q over delta T, charge over time, taking the derivative of the rate of charge flow, if you want, that's current. And it really boils down to charges can move along a wire. And so current is a really important facet in electricity. And if you're ever trying to light up an LED, typically an LED, the ones that we're going to handle on a regular basis, they're almost all specified for about 20 milliamps of current, which is a current rating. It's a small amount of current. High amounts of current would be like a vacuum cleaner draws 6 amps. And so that would be somewhere in the ballpark of, I don't know, maybe 1,200 times, no, 300 times as much current as the LED. So vacuum cleaners take lots and lots of current. Our little LEDs that we'll be playing with take very small amounts of current. And this is the official definition of current, which is very technical. But it's interesting to know that it's very, very small amount of charge that's carried by any single electron. It's some very tiny number with a 0 with 19, a 0.00000. There's a whole bunch of zeros. There's 19 zeros, and then you start to get to meaningful numbers. So it's a very small amount of charge and a lot of electrons flow in order to make a current happen. Another thing that's worth mentioning is alternating and direct current. This didn't even make the first slide of 5 things. Alternating current is what's in the wall. It's what's powering most of the things in your house. But all of your electronics, they're all taking the alternating current from the wall and they convert it down into direct current for inside your electronics. Computers, watches, LEDs, they all like electricity to flow in just one direction. And when that's the case, we call that direct current. It's flowing in one way. Alternating is when it shakes back and forth. And if you're wondering, AC/DC is all about alternating current, direct current. It's a fun band name also. And this is the classic debate between Nikola Tesla and Thomas Edison, which is fascinating. There's a ton of good history on the fight between those 2 characters and their supporting power companies. And ultimately, alternating current is what everybody's house has, because this little sort of yellowified circuit down in the bottom, that's all it takes to go from alternating to direct current. And so to go from alternating current in the wall, you just need a bridge rectifier and something to sort of smooth it out. And that's the bare minimum that it takes to go from wall power to your laptop. Although you just use the charge brick. Don't try and make your own converters. Voltage is what I would call is the energy of a circuit. And so voltage gives the ability to do work. So inside of your circuits, they're all powered by different voltage sources, different ways to apply power. Batteries are what most people will think of when they think about giving voltage or plugging into a wall. And so here I have a bunch of different batteries to consider. If if voltage is tied to the amount of energy that a thing has, it's interesting, and people might have counterintuitive ideas about how this works. Early in life, I thought that the bigger the battery, these are all alkaline, like the normal batteries, Duracell, Duracell, or Energizer, or any of those. I used to think that the bigger ones had more voltage, they had more like energy in them, and that's sort of only half true. Every one of these size batteries, they all have 1.5 volts per cell. So every alkaline battery is 1.5 volts labeled across here. And they have different sizes because they have different amounts that they store. So different sort of supply that they can hold on to, and different rates that they can give it to you at. So it's a little complicated and nuanced to deal with all this, but D batteries are the big ones that can give out lots of current. Those go in the big heavy duty flashlights. AA's and AAA's go into like TV remotes and the old Game Boys. You would play with a AA battery. And 9-volt batteries, if you ever open one of these up, and I should not officially encourage, I suppose, but it's definitely fun to do. If you ever open up the can on a 9-volt battery, inside you'll find 6 little tiny batteries that are smaller than the AAA. They're very tiny little batteries. Sometimes they're little rectangles, sometimes they're tiny cylinders, but there's 6 little batteries inside, because 6 times 1.5 is 9. And so it's an interesting way to get very low current supply out of a battery with a fair amount of voltage. Everybody this week is going to get a coin cell battery. This is a lithium ion battery. These are solid inside, and these lithium batteries give out 3 volts for just one of their cells. So you don't have a bunch of them in there. It's just one battery that gives off 3 volts. So that's twice as much. Then there's these weird squishy lithium polymer batteries. These are what are inside your cell phone, or if you do drone racing or like RC car racing, it's almost always lithium batteries at this point. And those have 3.7 volts per cell. So your cell phone's running off of 3.7 volts or less. Lead acid batteries, like in a car, that's 2 volts per cell. So if you have a floodlight that's like a backup power supply, that probably runs on 6 volts or 3 cells. And then nickel metal hydrides, these down here, these are 2-volt batteries. These were those rechargeable AA's, or some tool battery packs or nickel metal hydride still. And these were sort of swap-in replacements for the 1.5 ones up here. But that voltage supply is what gives you the power to do what you're going to do. And there's lots of different ways that you can supply voltage, that you can supply power. But thinking about what it is and sort of knowing that number for whatever it is you're working on, does it need 5 volts? Am I getting 6 volts? Just sort of being aware of it is useful, so that you don't get wildly out of track and have something that needs 24, but you're only giving it 5, or can only handle 5 and you're trying to give it, 48 volts. So just keeping that in mind, that they're all sort of in the right scale, can be really helpful. Although you can definitely go deep into the weeds with all of this. Another thing that's big, and this is especially true for wearables, is you want to be conscious of power. Power is how much energy gets used. And this essentially approximates to how much is it going to heat up, or how big of a power supply do I need? And so power is something that you calculate or you can observe. Power is your current draw times the voltage that's being used. And you won't need to do a lot of math with this, I promise, but it's just good to think about, like, how much power, how big of a power supply are you asking for? How much power is going to be required? If you're looking at the things we're looking at, this won't be a concern. If you're going to work with the LED sequence we give you, you'll be totally fine. But it's why it would be a bad idea to try and build a wearable jetpack, right? That's a lot of power that you're going to need to carry yourself up off the ground with a jetpack. And so that's what makes them dangerous, is that you've got lots of power that needs to be applied so that you can make that sort of thing happen, that you could lift yourself up off the ground. And so power is something that we definitely want to consider. Most people think about the big power lines overhead, but power is a consideration that we'll have to think about a little bit, and is definitely something that's worth considering when you're looking at projects, because you want to think about how much power is it going to use? How much of a battery pack do I need to have? And so those sorts of things are all going to come into account if you're starting to build mission critical stuff that really needs to matter. I've got, and I'm just going to grab it. It's right here. I've got a jacket that's a wearable that I have made in the past. It's sort of in view here. And it has a little, let me stop my share so you can see. I know I've got this little presentation thing, but that is the jacket. It's got that green stitching on there. And here's a little tiny battery pack. Builds a couple AA batteries. And when I press this, it lights up. It's a fun trick. We're going to talk about wearables a lot, but this thing, I'll wear this on Thursday just so that you can all see it in person. But this little battery pack is good because I know the power draw of this system. This battery pack is good for, I would say, maybe 10 hours of this thing being turned on. So understanding your power and your energy draw and the sources, the more if you want to calculate that in advance, like if you're building a lunar lander where you have to get it all exactly right, you can do all that math. For this case, like if my batteries die a little early, the party ends a little early, but it's not that big of a deal. You know, if it dies and I'm still, you know, out at the high school football game and my jacket's just turned off, you know, those sorts of things are interesting to consider, but not necessarily the most pressing issue for somebody who's just getting started. So back to screen sharing. Cool. And the last one is resistance. So we're going to talk about resistance also. This is an important part of the whole thing. Resistance is an opposition to flow. And it's an important thing to keep in mind if you want to have a bunch of LEDs. The LEDs that we're going to be putting into things have resistors with them, so you don't have to worry about this. But it's the opposition to flow that you might have to put into a circuit to protect some pieces or parts. And so usually if you're going to have an LED, you need a resistor. And for the LED sequence that we're going to be working with, they have them built right in. So it's important to know that this is a term, an idea that we'll come back to from time to time. But for right now, it's just good to remember that this is what a resistor looks like, or they might look like little tiny things, but they're an important part of circuits also. They keep your power draw lower by having resistance in them, or having resistance in the circuit. And so those are important pieces to take in mind. Other terms that you might want to think about are series and parallel. Parallel circuits this is a battery pack down here on the bottom of these two. And so a battery pack, these are three lights, let's say, that are all in parallel with each other. And so each one of these gets power independently, and they can each be turned on or off individually if you have switches there. Then in series, they're all sort of in a row, and current has to flow from one to the next, and there's no alternate path for it to go around. And so these are terms that probably were long since forgotten, but can be useful for what we're about to do. Whoop. And well, I want to go back to here. As we talk about series and parallel, there's a slide in here that I think I've lost, but if I put in a switch in each of these two circuits, series one, if I put in a switch, I'm going to turn all the lights on or individually control them. Whereas over here, because they're on sort of separate branches, I can individually control whether the light is on or off. And so depending on how fancy you want to get with your circuits, you can start to plan them out so that you have some that are turned on, some that are turned off, and you get a really interesting sort of an effect by being able to switch your lights at your command. Now, if you're way into this, you've got 1,000 questions and you really want to go a lot deeper, these videos, the crash course stuff on circuits, they're fantastic. The lady who narrates these is awesome. She's got a PhD in physics and engineering, I think, and is really a great communicator. They're fun animated. They're lots of fun. They're really good videos. I would encourage you to watch them. But circuit planning itself can be, if you're trying to do it carte blanche, can be tricky. But I would encourage, don't try and do that from nothing at the very beginning, because any sufficiently advanced technology is indistinguishable from magic, is the famous Arthur C. Clarke quote. And so just trying to keep your eye on the ball and follow instructions is the best way to get started. So if you're trying to design a circuit, you're going to want to ask yourself, for any electronics project, sort of these things. What's the primary goal? Do you want it to light up, maybe? What constraints do you have? What are the limitations on your project? What components will help you get there? How will you control it? Does it need to be very smart, or can it just be kind of an on or off device? Does it need to have any sort of a brain to it? and how much power is required, and how will you give it that power. And there's a lot of variety that can happen in here. Some of these really need to be considered. I've had, for things I've personally built, I've got wearables that, like that jacket is a little battery pack with 2 AA batteries. The backpack that I wear has some lighting that I put in new batteries, and it's half dead. Half of the chain died, which is a bummer. But little battery packs can be totally fine. I've also had I made a Ghostbusters pack for Halloween one year that I would wear around, and it had like the ectoplasm gun and everything. And that took a lot of power. So I had to carry around a big lead acid battery for Halloween, which is not a great plan. But fine, it needed more power. And so I just needed to huff it around in the backpack, which worked out okay. But those sorts of things you'll want to think about for what is it that you're trying to build, and how do you want to make that happen? What is it that you're going to work on? Those are all the details that you'll need to think about. And so as we're going to be working on this, we're going to think about, how do wearables fit together? Sort of, how do you build something that's wearable? And there's lots of different ways that you can build it. These are many of the options, and not even a comprehensive list, right? There's breadboards and those things. We've built some circuits like that on breadboards. You can solder onto perf boards, like up here in the top right. There's printed circuit boards like this one, or like the Arduino shield that we did. These two in the bottom left, those are flexible circuit boards, which is a really cool thing that has recently become sort of affordable. If you wanted to design your own and order those, you can totally do that. It's not the cheapest, but it's not terribly expensive to design and order your own flexible circuit boards. This is free soldering. So if you wanted to build an LED cube or something else where you just solder the wires together sort of in suspended 3-dimensional space, that's really cool. But the big one that we're going to focus on is this over here. And this is the Wearable Electronics. This is sewn in circuitry. And so it looks like hand embroidery, but those threads are all conductive. And so those are actually the wires that are conducting the loops, so that you can get your circuit to go from where it is to where you'd like it to be. And there's a number of ways that you can work with that to make that happen. But in this particular example, you can see up on the top of the lapel, that's a GPS unit. So it's the thing is able to track where it is in space on the planet. And then down here, those 6 things, those are all LEDs. So it'll sort of tell you if you're, I think this jacket would light up if you're getting close to home or something. And so it would tell you if you're close to home, and the colors would change by how far from home you are. And then underneath, there's this little controller board that's doing all the logic, interpreting what comes from the GPS and controlling the LEDs to be off or on. It's a really neat look. Some people really like having sort of the circuitry of that exposed. Some people really want to have it hidden. But either way, this is what we're going to try and focus on this week, because it gets you to have a real hands-on experience with all those electricity concepts. And it also gets you to take a look at these components and sort of make sense of circuits from their raw pieces. Now, if you're thinking about circuits and you're trying to wrap your head around those still, the big analogy that people use, they like to think about water as an analogy for it. And so here's sort of like one of those long log flume rides. I don't know where you'd ride one around here. Back in the Midwest, we had Cedar Point, which was a theme park people would go to. They have all sorts of roller coasters. They have a big log flume ride where you'd go up this conveyor belt, and then you'd sort of ride around at the top. Then there was one big drop with a huge splash. Everybody liked it, sort of like Splash Mountain at Disney. And then you'd ride around back to the bottom. No story on the Cedar Point one. It's just like go around, go up, go around, go down, and then that's the whole show. Lake compounds. That sounds fun. I'm sure that's a fun place to be in the summer. Not now, but doing this sort of a thing, you're lifted up, you go around, and then you come back down. This is very much like a circuit. So over here, this is your battery. It injects some energy. You're put into a higher energy state. And then sort of those electric charges, they flow along the wires until all of a sudden you get to something, and that thing uses up a bunch of the energy, and then it sort of floats its way back to the bottom of the lift. And so that's the pattern that circuits really follow. People have used all sorts of water analogies to try and make sense of it, but it's not wrong in any way, in a lot of ways, to think about it as water flowing through a pipe. Electricity flowing through a wire is a lot like water flowing through a pipe. And so you're going to need to think about how do you make it a complete and closed loop as we go through our discussion of circuits. And for us, the battery pack will be that little CR2032, the little coin battery. And the drop is going to be the lights that you're adding into your circuit. And so you'll have lights, drops like this. There's a couple of ways that you can make drops happen. But that energy using piece and the battery are going to be something that you're thinking about in tandem. So you can do it with a reservoir at the bottom, a little pump, and then a reservoir at the top, and then your circuit lets you go through. You could do this sort of continuous thing. All of these are interesting ways to think about currents and water flow. There's a lot of complexity. We could go very deep in the weeds, but it's best just to sort of move on. One important feature, though, is to think about switches. And so as you're building circuits, people usually don't just want to plug them in and have them run for forever. They want to be able to turn them off and on. And so a faucet is a really good analogy for a switch. And so these are some old school switches over here. The logo for a switch is this bottom one, where it's just sort of a line that's like a door that's ajar. And so that's the common way to denote most switches, that it's just sort of a disconnected wire. But switches can take all different sorts of forms, and all you're doing is making or breaking a connection. These like little toggle switches are in some houses. You might see these if you walk into a very old house. This like big knife switch is good for if you've got lots of power that needs to go through that metal. Those are sort of the big cathartic ka-chunk switch that does a lot of fun action. And then we know switches are so important for turning things off and on that we very often will like draw digital switches because they're intuitive. People make sense of them and they're fun to click. So switches are really helpful, but they're a lot like a faucet in that they can control, is current going to flow or is it not? Right? It can let the electricity flow inside of a wire and turn it off and on just like a valve, just like a faucet. So that's basically what a switch is. And we'll be playing with those as we think about the circuits for this week. So headed back to series and parallel, if you add in faucets or switches in your circuit, you can add them in so they can shut off all of your lights. And if you're going to do that, you'll put the switch in series. For any light switch in your house, they're in series with the lights. So you have some power source in your house. That's this battery pack down here. The switch is the thing over by the door. And then the lights are up in the top of the room, right? So when you flip the switch, it's directly in series and you can turn on or off the lights that are all connected. And so that way you can control what's going on. And this series, your switch needs to be in series with the lights in your house, but they don't have to be lights that are all in series with each other. And almost always your lights are set up like this. So you might have one switch that can control all the lights in the room. And then you might have individual switches. Some kitchens have like fancy zone lighting where you can flip switches and like the light over the sink turns on and the light over the oven turns on, and you can switch on and off different pieces, or even like press a switch and the whole room turns dark. So if you get creative with how you integrate switches, you can control little zone pieces, which can be really helpful. Last year, Kate made a shirt where she was able to integrate two switches in a way that would let her light up one part of a shirt or another. And so she could use her switch carefully to try and make a connection that would get her what she wanted. It would display different things based on the connections that she wanted to make. And we'll explore that a little bit in a second. But that's a really fun trick to be able to do. Another thing that you need to watch out for, and so this is definitely true, especially with wearable circuits and sewn in conductive thread, is that you'll always want to think about the fact that current will take the path of least resistance. And that means that if current has an ability to sort of shortcut all of the drops in your circuit, it doesn't have to go through the light that takes up a bunch of energy. It will absolutely go through the shortest path. And so if you have a connection that gets back from the battery to the battery a lot faster, it's going to do it. This short circuit would have these three lights be just two lights. Instead, it would sort of cut out that third one and you'd lose that one in this circuit. The current could go along here, up around, and then back down through, and you'd shortcut through your circuit. That's a short circuit. And then over here, this one has a direct path to come out of the battery and then back through the battery. This short circuit, I would say, is more catastrophic. It would actually cut off all three of the lights because it would be a lot less resistance to go through the short circuit than to go through any of the lights. So short circuits are something you're going to have to watch out for. And the opposite of a short circuit sort of is an open circuit. And when you have switches, you're controlling whether they're open circuits. And so switches, you're controlling open circuits or not. Short circuits are when things go wrong in the other direction and you have sort of closed circuits in places where you don't want them to be. And circuits, if someone hasn't told you this yet, circuits are like fences. A circuit works when it's closed and a fence works when it's closed. A fence does not work if the gate is open, and a circuit does not work if the gate is open. If you're trying to keep all your sheep inside the field and you open the gate, the fence isn't going to work to keep them in the field. So you've got to be conscious of an open or a closed circuit. Those are things that you might want to have. If you're talking with people about your circuits, you might want to know those two words. But that's sort of that's a whirlwind tour of science. And that's been a lot. I'm a science teacher, so thanks for indulging me. Sorry for it being a little longer than anticipated. But let's talk about modern commercial wearables. What are the wearables that in the high-tech world, things that we would like to do? So most wearables, if you're thinking about a wearable tech, if you're asking someone on Wall Street about wearable tech, this is what they're going to tell you about. The Apple Watch, Samsung watches, these like fun calculator watch things from the 80s, nice headphones, maybe AirPods count, a Fitbit definitely could be a thing that's in there. All of those different details, those are all wearables in the current like high-end electronic sense, where it's something electronic, you put it on your body, you carry it around and you wear it. I think even a cell phone sort of like half counts. I feel like I'm missing a part of the things that I need to have on me all the time. If I've left my cell phone somewhere, it is in the same category as my wallet. Like if it's lost, it's a bad day. Those sorts of things are definitely wearables in my mind. So all of these are in the sort of big ticket wearable items. Probably we're not going to be building these this week, but wearables in the hobby space can cover this sort of a realm. And so I've got this video that I'm going to play. This is also a very high-end group that has done a lot of work to make this really good. But over here, I'm going to just talk and turn off the audio for this. This is another example of wearables. This is a dance troupe that they've got EL wire over their entire bodysuits, and they're using battery packs and timing and electronics to control when they're on and off. So they're doing their dancing and they've got themselves all lit up. And by controlling when the lights are on and off, they can sort of make these magical things happen on stage. And you can see the suits are definitely a little less impressive with the lights on, but it's a really cool thing. And all the dancers in this troupe get really well integrated into how this works and how this fits together. And so it's a really cool, it's a fairly long exploration of how this works. I would definitely encourage you to check it out. It's a cool dance troupe for sure. And they have been featured on TV many times because they're famous for being able to do this and do it really well. So it's lots of fun. Look at this crazy control circuit that they've built in. Those are the sorts of packs that they're carrying around on their body with the batteries and controllers and all those sorts of things that it takes to make this operate. They just like stuff that in an inconspicuous spot, and then they can make their whole setup work on the fly wirelessly to keep all of the suits in sync with each other. You can definitely do more wearables that fit into all sorts of categories. So these are wearables up here on the right, where you might have EL wire or LEDs that are making yourself glow. That's a really cool use case. For most costumes, people want to do wearables that look more in this camp, that cover this sort of a space where they're able to integrate lights into what they're wearing. It's a really fun way to integrate. And I have seen this be used in things all the way from like this dance troupe to the Met Gala. There's been people with light up clothing all like across the board to Halloween. It was the Cleveland News like took a collective awe one year when there was a little 4-year-old girl in a light up stickman costume that her parents had made. So she had like a little circle for a head and then glowing arms and legs. It was very cute. I'm sure I'll find that video and share it. But those sort of light up things are really a fun space to be able to work in and play with stuff. So Some of those are professional level, but we're going to take a look at how these wearables can really be something that you can play around with. And so there are definitely specialized wearables that you can get into. There are some people who have come up with wearable shirts, and I just want to point out the sort of like oxymoronic value of that. Shirts with electronics built into them, and so because they're a wearable and a shirt, they're called a wearable shirt. It's just sort of funny. I really like that happened. Thanks a lot. So the good news is that even though there's a lot of crazy details with all of this, you can wear most small electronics, right? Most things you can just sort of put in your pocket and they become a wearable. When I was talking to Lior about this unit the first time around, he's like, "Oh, I've got a wearable," and pulls out a cell phone, right? Anything that you carry around can be a wearable. I'm going to give you some strong recommendations. Try and do things under 12 volts. You don't want to carry around more than 12 volts just for the sheer sake of practicality. The batteries start to get too big after that. Under 1 amp of current. So if you're measuring your current fastidiously, and you may not be, and that's totally fine, under 1 amp is what I would recommend, and never ever break the skin. You can definitely find more research and details. There's people that have broken all of those rules happily. My recommendation would be don't break any of them. Under 12 volts, less than 1 amp, and don't break the skin. Your skin is actually a big resistor. So your skin is about a mega ohm of resistance. So it's really hard for electricity to come in through your skin. But once it's in, you're basically a big bag of water. So you got to be careful. Don't try to not let it poke through your skin. If you tell me that you're doing something where you're integrating electronics into your body, I will stop you, because you should not be doing that on your first round, for sure. But there's all sorts of really cool things that you can do. In general, I think that wearables, you're going to feel more successful with your wearable projects. They do a lot better if they follow these few simple guidelines. Your things should be bendable in general. The more bendable your electronics are, the better off it's going to be. Not having hard plating makes it a lot easier. Most people don't wear hard plated garments, rigid garments on a regular basis. Some people do, but most people don't. And so typically it's hard to hide like a real solid circuit board or big battery pack underneath a hard plastic part of a garment. And so making them bendable really works well. Low power batteries, sort of low profile batteries, can be helpful. If you can tuck them maybe under an arm or in the small of your back, it can be good to hide batteries in some place. Or if they're coin cell batteries, you can just sort of like have them tucked away on the inside of the garment and no one will ever see it. Most of the time with wearables, people want a simple interface. You don't want to have a complicated control structure where you have to press some buttons and flip some switches to get it all to turn on. Most of the time, you just want a simple, like, if I clip this snap together, the whole thing turns on. Some sort of a simple interface that doesn't have a whole lot of complexity to it can be really helpful. You want it to be built relatively sturdy so it can handle the elements. If you do some sewing with conductive thread this week, I would recommend that you try and solder it together to have it a little bit more rigid if it's the kind that will take solder. And if not, you can put a little clear nail polish over the joints and that can hold it down. But while you're doing that, you want to make sure that it's got a really good connection as the nail polish is going over, so it doesn't like wick in and get underneath and break the connection for you. And another thing that's helpful is for your wearables, you want to have them be able to handle intermittent like power breaks. So don't try and build your own spacesuit, right? A spacesuit needs to have consistent power all the time. And if you lose power, bad things are going to start to happen. We don't build a jetpack that, like, if power dies for a half of a second, all of a sudden you're flying towards the ground. So we want to have things that are safe, that generally can handle, that are lights. And if they blink off for a second, it's no big deal. The party goes on. So for wearable technology, in general, you can look up all sorts of information for what kind of background information you'd want on wearables. They'll tell you all sorts of things that you can do with that. Activity trackers are a big piece. You could build your own. We do have motion sensors that you can attach in to wearable circuit boards, wearable Arduinos, and that totally works. But I think for us, a lot of what we're going to do is just sort of like wearable tech that's a little bit simpler. Oh, here's one interesting wearable electronics. This is an NFC ring. So if you've got the right setup on your computer, you can use one of these. And let's click on it a little bit further. One of these NFC rings, you could use that to like log into your computer with a ring if you really felt like nerding out that much. You put a little NFC reader on your desk and then swipe your ring over it and it would log you in. It's a fun trick. I definitely have dreamed about having a desk like that where I can just wipe my hand over and it logs into the computer. But that said, the best place I think for you to get information about wearables is to Google it or to go to Adafruit. These are the two sources that I think are going to be the most inspiring this week. And in a second, I'm going to pop over and actually like go explore Adafruit for new ones. But the internet, this is definitely a darling space of the internet. Wearable tech has become a fun maker space, a fun hobby space where you can have all sorts of things happen. And there's a whole range of wearable tech that is out there. So there's things that are specifically built to try and fit one niche or the other. And if we just pop over to, if we just come over to Chrome and Becky Stern, we're going to see her in a second, but she's an absolute pro at all of this. But if we just search wearable technology, wearable technology projects, probably. If we do wearable technology projects and we come into here, we can look at images, and there's just going to be a whole treasure trove of wearable technology projects that you can buy, look at. Here's like LED panels that are bendable. Here's sort of a weird watch that you could make on your own. There's all sorts of different, that's a strange activity tracker. There's all sorts of wearable tech that you can do. But if we go to Adafruit wearables, this is really where Adafruit really shines in this space. And so if we go to this wearables product category on Adafruit, and at this point, I realized I'm sort of endorsing them as a reseller, or as a business, but they've really got some great stuff. So with this, they sell all sorts of starter packs, all sorts of project packs. They've got tons and tons of tutorials. The things that we've gotten for you this week are these LED sequins. So these are little tiny things that you can just sew onto garments. We're going to get to them in a second, but they're just little lights that you can attach in, and they work like a charm. There's stainless steel conductive thread and all sorts of things that you can go through. But within this, it's a big scrollable area. You can definitely do the like learning section where you can check out these cool sneakers that you could make that light up on the sides. You can definitely buy a product like this at this point, but you used to not be able to, and they came out here first. I just want to say, or I'm pretty sure they came out here first. It's a cool trick to be able to add this. And that's Becky, who has come up with a ton of these designs. And this is a full tutorial. If you wanted to make those sneakers, this is the stuff you buy, and this is how you make it work. So you can follow through with these instructions and just do exactly what they say to make it all happen. So there's tons of examples like this where you can look at, there's a whole wearables category. So if you wanted to make stick person costumes, if you want to make all sorts of things, there's a bunch of opportunities. Here's a birthday boss tiara that looks pretty fun. An infinity mirror collar that looks pretty neat. There's all sorts of cool options for stuff that you can make. A little Hanukkah sweater, that's nice. Things that you could build that you could use as sort of an inspiration from here. Adafruit does a really nice job of documenting these. Of course, they say buy all of our stuff. Here's how to do it, and this is what you need to buy. And so there's some cool options to make all that happen if you wanted to. The big ones that we're going to work on are, let's go back over to our slides in here. The big ones that we're going to focus on are just a few projects. So things that you could start with, you just need an idea and you can spin it up from there. Watches, dresses, jewelry, handbags, jackets, masks. There's tons of opportunity for cool stuff. I should have grabbed it out of I have my like maker cupboard right over here on this side. And I have a fiber optic thing that I've always wanted to make into a mask where you put an LED in from the side and it sort of sparkles across the whole mask. Maybe I'll get to that this week. That'll be fun. But in here, here's another good inspiration for a project. This is Becky Stern, who made the sparkle skirt while she was working for Adafruit. And this has got a couple of really cool examples. I'm gonna let this play and it's not gonna talk, but you can see on this skirt, it sparkles as she walks. She's using the Flora system, which is a wearable targeted Arduino. It can sense motion, and then when you move, it twinkles those lights on and off. And so you sew together all the pieces, you're using conductive thread as this happens. And another thing I want to point out is I'm pretty sure that's a laser cut fabric. Is another interesting use case, is that you can laser cut fabric really nicely. It works super well. You'll want to do a test cut if you wanted to do a complicated design like this so that you minimize burning. But you could totally laser cut fabric as sort of a cover and then hide all of your electronics behind it. So this is a cool application where you can get garments to sparkle. The things that we're giving you this week today, or like that we'll have in MakeHaven, they are not enough to make it sparkle. You need to add in sort of a logic board, but you could make all of the connections and make it light up. So this sort of a project is totally within reach by just taking all the things that you're using for wearables or for textile work in general, and just adding in a little bit of circuitry. And now you've got something that's really unique that sets you apart in lots and lots of ways. And this is like in the category right now of high-end fashion. Every so often we'll pull out a wearables project like this, and it makes it into big fashion news that you have electronics like this built into your clothes. Also, this lady's Instagram is fantastic. She's really a powerhouse of making things. There's a lot of pet pictures, which is never bad either. But she, for a long time, has been a real pro at how to do lots of wearable electronic stuff. So I would totally recommend you check her out in there in general. She's totally a role model. I would definitely like to meet her. She's from New York. And so I feel like that's not a 0% chance that I could meet this lady one day and have a conversation. But in general, if we're trying to circle this back to what are we going to do, this is essentially the circuit that we're going to try and make happen. We have 5 LED sequins that we want to give you, that we want you to be able to use, and a CR2032 battery and battery pack. Basically, this is the circuit that you're going to make, but using slightly different components. I just didn't have them for building this diagram. You'll have a battery pack. There's a switch on that battery pack. There's a series of these sequins, and they're the sequins that are on Adafruit. If we come up and look at their LED sequins, these are the things that we're talking about. Search, close this and do the LED sequins. These LED sequins are what we're talking about. They come in a little pack like this. And if you're looking closely at them, they've got an LED over here. That's this glowy part. This is the resistor that has to be with them. And they're all tied together onto here. They're silk screened on, a little plus and a minus, so you know how to sew them in. And when you make that connection, when you do that sewing, this is totally something that you follow some instructions and you can make this happen. This is using a Gemma, so using another small control board to light them up as you want. And it's a cute little hat. You can hide the battery pack in the fold of the hat. But it goes through the instructions of how you'd use these, how you power them. And this is pretty much the circuit that we're going to have. Ours, instead of these wires with alligator clips, we'll be sewing them into place. You can also tape them into place. There's a bunch of ways that you can make this happen. This conductive tape is fun stuff to use also. There's of these where everybody's going to get 5 LED sequins and everybody's going to get a battery pack that looks a little different than that, but basically it fits into this category. So if we're looking at these LED sequins, we're going to look at some of these things and then battery packs to go along with them. So back to the slides. Another thing that's useful, and we have plenty of, we can hand them to you also. I'll put them into the gift bags. We have metal snaps. And so metal snaps like the ones up here, these are sort of riveted in snaps, but we have sewable snaps. Those sewable snaps, if you sew them in with conductive thread, they become a switch. And if they're connected, it's a closed circuit. And if they're disconnected, it's an open circuit. So you can add them in as a second way to make a connection or not make a connection. And so it's a fun way to make a switch where you can control what's on and what's off. There's some really cool stuff that is available when you do that. Kate last year had a shirt, and I should have gotten a picture of it. I'll try and pull it up when we do show and tell and other people are talking. But you can do that. Ooh, good question. Are zippers conductive? If they're metal, they'd be conductive. So as long as it's metal to metal contact, you could use a zipper to make contact between things. And so if it's a metal zipper, you could do some interesting stuff where maybe one of the panels is ground and the other is power, and you sort of zip it up. And as you zip, you get more and more connections. And as you unzip, you get less and less connections. You can get really creative with how you use that flow of electricity in a shirt just to make weird things happen. If you wanted to have like maybe a zipper on a pocket, and you unzip the pocket and things start to light up, or they start to go away, there's all sorts of cool options. In your circuit, if you're trying to imagine the LED sequins, each one of these like yellow container areas, that's what's in the LED sequin, and you'd want to wire them up in parallel, with the red being like the positive side and the black being the negative side. That's the setup you'd want to go for. A parallel circuit is going to be the best way to make these happen. If they're in series, you probably will only get one to light up. You definitely want to do them in parallel and test them all before you sew them in. Once you start using that conductive thread, it becomes hard. You've got a lot of thread pulling to undo a circuit. So building in a wearable circuit that you've hand stitched in, you want to take your time, go nice and slow, and don't rush it, testing all the time to make sure that your wires aren't crossing, that you're not accidentally short circuiting, to think about, are they in parallel or are they in series? Getting it all to work the way that you want it to is a really helpful part of getting these wearable circuits to work. It's a really great practice for getting electronics to be working in the ways that you want them to. And we're doing, we've got a few tips for this. I'll be in on Thursday to help. So if you're trying to solder wire loops onto things, I can totally do that. Any of the breakout boards for any electronics, they can all become wearables. You just need to like sew on a little wire loop to the end so that you have something to grab onto. The LED sequins and the boards that we're going to have for you, they're pretty much good to go from their setup. So you don't need to do a lot of setup or prep work to get them ready to be wearables. They can be wearables right away. Ooh, and that brings me, I do have a couple examples. And so I want to show you these because I can hold them up. Here is an example of a wearable. It's a little hard and it's a little strange on this like stripy fabric, but in here I've got this thing in the middle. This is the battery pack, and so that's a CR2032 battery. It's like a little coin cell battery that's in there. My LED sequin is this thing right here, and I know it's going to be way too small to see, but that's the sequin. And then on the end, I've got these two metal snaps. And so those two metal snaps, if I bring them together and make contact and snap it together, sort of snapped it together, just like that, now that LED is glowing and it's adding extra light into this strange scenario. It's a lot more fun to see this in person. And if I point it directly at the camera, you can see it's a bit harsh. I'm getting a little sun flare on my camera, which is kind of fun. But if it's covered, if it has to pass through some other layers of fabric, a lot of people prefer this sort of a look because it mutes the brightness a little bit. It tames it down by having it go through just one layer of fabric. And then you've got definitely a notable bright spot, but it's not quite as glaring. Things aren't quite as aggressive. And that's all just being operated by this little snap that is sort of hastily sewn on here. And if I have this glowing and then disconnect, it turns off, reconnect, it turns on. So it's a simple little circuit. The thing that's tricky about this example is that it's all in a line, and the stitching on the back, I know it's hard to see, but the stitching is all sort of in a line. And it's got lots of long tails. I would be careful as you're sewing. Any of those that contact in ways that you don't want them to, you start to get a short circuit, and then things can start to go awry. So being careful and deliberate about your circuits here pays off in the long run to make sure that it's consistent and that it works. I've got other examples. This one, I need some power. Ooh, Kate's party shirt. That's let's see, here's Kate's shirt. Thanks for the link. here's the 6-second view. So this is Kate's shirt all pulled up. Inside of here, we've got one LED that's turned on and it's green for party mode and a red LED for introvert mode. So you can see she's got this down here. It's a little tough to see in the corner, but she's totally just got a set of snaps that let her make the connection that she wants. So you get it working the way that you want, and you can control which connection is happening inside the shirt. It's a really fun piece. I'm definitely going to throw this into the slides for future rounds, but this is a cool application of all of this so that you can play around with these things.
Hey, Corey, I don't think you shared your screen for that.
Oh, crap. Sorry about that. Now you can see it. I was enjoying it. I was having fun. This is the video. And so you can see she's got the green light on, and then down in the bottom corner, there's a snap that she's playing with. And as she does it, she can control whether the green light's on or the red light's on based on which one is connected back to the battery through the snaps. So it's a ton of fun. It's a simple circuit, right? This one's connected or that one's connected or neither's connected. And you get a really nice way to build a wearable where you can have some interactivity or some control on what it looks like. It's a cool look for sure. Let's see. And then that's the link. Thanks for sharing, Steve. I appreciate that. And thanks to Kate for putting it out there. So now headed back over to the slides. So if you're playing around with this, the things that you want to think about is the CR2032 and LEDs. They're great. They're super hardy. It's really hard to destroy either of those things. So a shirt like Kate's is going to be very well worn. All you need to do to keep it safe is to be sort of, I wouldn't throw it in the washing machine necessarily unless you're really confident in your embroidery stitches. And even then, I would probably try and put it in the hand wash category if that's a thing that you do. And then pull the battery out when you're going to do it. So those are really the constraints. For sure, take the battery out when it goes into the wash. Not that the battery will hurt anything. It's just more weight sort of slamming around in the electronics. Practice with alligator clips is a really good thing to do by the electronics bench. We have a ton of alligator clips on wires, so you can totally connect that way, get things up and lighted, and then sort of go from there. And if you have a battery board and the holes are too small for you to stitch, you can solder on little jumper wires that have then an unshielded loop on the end. They give you sort of more area to grab onto, depending on how the sewing is going for you. And then definitely diffusing that LED light can be really helpful. Kate had it behind the shirt instead of on top of the shirt, can make it look a little nicer. And then how much do you want to, some people really like the electronics out and sort of in view. And other people want to hide them quite a bit. On my jacket that's on the floor, all of the stuff that you could see was just the lighting that was out there. And then on the inside is where I hid all of the like nasty wires that don't look nice, that keep it from being such a nice showpiece, and hid all of the electronics away from people so that they weren't looking at it. So thinking about how you want to build your system like that can be really helpful. And there's tons of cool options. Also, it's worth mentioning that jacket is the same stuff that those dancers wore, which is EL wire. And I should Google that while we're in this space. EL wire is not an LED. It's a different thing. We have a little bit of this at MakeHaven, but not like enough to give to everybody. So if you wanted to see it, we can definitely fire some up. I have some that I can show you. This comes in wires, it comes in strips, it comes in panels. And so you can get all sorts of different types. But this is another cool way to add light to things. There's a little bit of skill that goes along with it. And you can see Becky Stern is again the one who's showing off, but there's all sorts of really cool things that you can do with it, where you can get shapes that glow, where you can get it into panels. You can add it onto furniture is what they were showing there. And you can even like modify it yourself. So there's tons of cool ways that you can get this stuff to work. And they're going through sort of the soldering process. I've done a project where I solder a lot of EL wire, and every one of these solder joints, I just want to say, they're all spots where things can go wrong. So if you're going to use EL wire in a project, try and have the least amount of junctions you can is my genuine advice, because as cool as it have discontinuous pieces, they all become failure points. And the more you make it just one continuous wire, the more likely you are to have a nice long lasting piece. Those dancers, they almost always used just one continuous string whenever they could to light up whole zones of the shirt. You can make little blackout sections with heat shrink, is a really cool trick too. So EL wire works. You need a sort of battery pack to go along with it. This doesn't work as nicely as the CR2032 and LEDs. This runs at, it sounds a little crazy, but it runs at 110 volts or 120 volts, but very, very low current. EL panels have been used for a long time as a way to do night lights, like very low energy night lights. If you just plug them into the wall, they'll sort of glow a kind of blue-green usually, and they're very low amounts of light, but just enough that like you're not stumbling in the hallway as you find your way to the bathroom in the middle of the night. And if they're always on, they take almost no money at all because they take almost no energy. So it's another cool technology that you can use as you're working on these things. But these are really the suggestions for what you should go after. The big things that I want you to start with should be just that. Just run in and do this sort of a circuit. We have all of this for you. If you want to do something else, you absolutely can. I would totally help you figure it all out. But this is a great place to get started. And if you wanted to add in sort of wearable things, like I'm going to stop my share. Here's another one that's got a wearable. These are Arduino boards that are just able to be added in. The brand name on this is a Flora, I think. And it's got a few sewn on LEDs with addressable colors. So these are RGB LEDs. So you can have any color that you want on them. They're addressable. So you can say, I want the second one to go to this color and the first one to go to that color, all in code. So this is a code driven project at this point versus the sequins and a battery. It's just sort of off or on in a very analog circuit kind of way. So if you wanted to upgrade your code into garments, getting a control board like this would let you do all sorts of control things that way. But if you just want to wire it up and have something that glows and lights up, or use some interesting switches to make fun things happen, you can totally do that also. So there's a lot of opportunity, but the real recommendation I have for this week is to just go after the primary design and then find your favorite constellation and sew that into a shirt. Or I think that I saw a good example of using like an embroidery hoop as a wall decoration, where like the embroidery hoop is a constellation, has the stars on the fabric all taut, and there are these sequins that are there, the sequins like on the back behind where the star is, and then you have the conductive thread sort of connecting the stars with maybe some decorative white dashed lines on top. So you can make a real neat look from having a few layers on an embroidery hoop and just hang that on the wall. There's all sorts of cool ways that you can make wearables or art that's textiles and electronics. But this is the best place to get started. This was something nice and simple like this, with lights and a battery off and on. And that's a good exploration of not only the wearables, but also like the tricks that it takes to get circuits to work at a very nuts and bolts level without the complexity of any circuit boards or any of that thrown into it. So that is the next steps, the things that you should start with. Go for this project. That's the goal for this week. I'll be in on Thursday and Sunday to help. And I hope that you're excited. Maybe we'll get people that make a sparkle skirt or that go after some other crazy wearables. If you want to do these, you totally can. Next week, I just want to remind everybody, is going to be choose your own adventure, sort of like an integration week is what we're going to call it. So you'll be able to integrate all the different things, all the skills that we've learned up until this point, and have some creative license to see what you're going to be able to make with all of that. I'm real excited to see what that turns into. If people will do wearables that extend, if you're going to do CNC work, if you're going to just go back to a couple other areas. There's not really any guide rules on it. It's really a chance to bring these skills together, because one of our core beliefs in the foundations class is that all these things separately is really cool, but bringing the skill set together and making them into an integrated group makes it even more powerful. And so this is going to be our first sort of structured exploration of that. We'll talk a little bit about integration purgatory and how that works next week. But we'll be thinking about how to take ideas like this and connect them to other ones and really extend into a much broader space. So that is what we're headed to next week. But this week we still have show and tell time. And so I am very excited to hear what you all were up to this week. If you did anything fun, exciting, hopefully to hear that you're healthy, and that we can all get in and try and play around in the space and build some cool e-textiles, or try the CNC embroidery machine out this week. Or if you weren't around for CNC, we could pop in and do that too. So for show and tell, let's go in order that you appear on my screen. So we're going to go top to bottom, and that is Lisa first.
I had a feeling. Okay, if I were to try to share my screen, how do I do that, or do something? I haven't yet, but then I have to go off of looking at the Zoom and look at my, my web page.
There should be a green share screen button that popped up, and it might be around.
You're right.
Mm-hmm.
So now, but I have to. So now I got to go find it. All right. Okay, but now I got to move you out of the way somehow. Let's see how.
Oh, do the share screen and it'll move me on its own.
Okay. Well, I thought I hit the share screen. You don't see it yet? Okay, I'm going to go back to the Zoom.
Not yet.
Didn't do that. I'm touching it.
You're good.
Okay, so I did that. Now, how do I get to my web page? I mean, where you
it still isn't showing up right now. I have a setting clicked, so it's allow. Oh, wait, we got it.
Okay, there we go. All right. So I just posted them here, and some of these things you've seen, but I did a lithophane. Corey knows all this, but I did a lithophane nightlight. So the image on the right, is it showing up?
Yeah, that looks great.
Okay. So, and that took 27 hours to print, as we know, because we made it ultra detail or something like that.
Yeah, nobody was there. None of the printers were being used, and it didn't use any more filament, right?
Right. And so we're versus the Mona Lisa in the middle, you can see how low resolution it is, but when it's hanging in the window, you can't tell. Yeah. So then let's see. So that was 8. So, and then for the Shipoko, I was just doing this to learn how to do it. And it was a lot of fun to do. And so I did in Illustrator, I made the file initially, and then brought it over. It's all vector, and we worked out how it cuts it. So I wanted to try the V-cutting tool, mill, whatever. And if were I to ever do it again, I'd want it to cut deeper. I stained the top of the wood so that I could see the lettering more clearly, and we didn't have time for the stain to dry. So, little fibers of the wood are kind of filling in some of the letters that I'd have to pick out, and it burnt some of it. So had I had more time, I would have put film over, like masking over it before we cut it, so I could spray paint into there and then peel it away. And then I did a keyhole on the right-hand side just to see. It's not a very pretty one, but it does work, so it could be hung. Oh, and I also went and used the router bit to do a 45-degree edge on it. So that's what I did.
Yeah, that's great. And it looks, I got to see this one in person. It looks really nice. And I'm curious to see the masking trick also. I think that would look cool, really sharp. on some of these, but I think it looks great. The burning, I think, looks like a natural feature in the wood. No worries there.
Okay, thanks everybody. Oh, how do I unshare now?
Yeah. All right. So let's
right.
see. I think I can. There we go. We're off. Alina, you're next up in my list. Can you tell us what you've been up to?
Yeah, I just got back on Wednesday, so I'm not up to date on CNC cutting, although I'm very excited for that. But here is a recap of my finished Christmas gifts. So this is mom's gift on the right side, and here's dad's gift on the left side. So dad's is the one that I've kind of been showing everybody step by step of. And mom's gift, I didn't take pictures the entire way, and this is just the picture that we took after she unwrapped it. So for mom's, I just followed a tutorial that a woman that I follow on YouTube posted. I love Tamara. She posts really helpful, like broad range of YouTube videos. There's like, this is exactly what I'm making, follow along as I make this specific thing, but then also shows like how to make different like types of joinery, and here's this interesting puzzle that I want to try and figure out how to make. So highly recommend her YouTube channel, and then this is her website where you can download the templates and things. So these are snapshots from the YouTube video since I didn't take any pictures of myself making it. And then here is the pictures of my dad's gift, finally all lit up. My first attempt at soldering it, and then this really beautiful canary wood. I just really liked this wood that made up his final box. And then I have a video of it changing colors, and it works. So
that's awesome.
Pretty happy with that.
Yeah, that's really nice. Also, Tamar, couldn't agree more. Fantastic YouTube channel. What a boss.
She's so cool. And she's in New Jersey, and all of her woodshop stuff is in the garage. And so she's constantly like bundled up and like, it's freezing outside, but I'm cutting wood.
Yep. I get it. Also, I feel like you knocked it out of the park on the project that was just like hers with those exotic woods. It looked really great. So great job on both counts. I'm sure it was a big win at Christmas. That's awesome. All right. Renee, you're next up.
Hi. So I've been gone for a little bit. Like I'm sure a lot of people were. I traveled. I went back home to Arkansas for a little bit and saw some family and friends. That was really nice. So just got back recently. I don't really have anything to show, but I'm excited to get back in the saddle this week and get making. I did make some Christmas presents, but I totally forgot to take pictures of any of them. I did some punch needle stuff.
Ooh.
But I just didn't take pictures. I made for my aunt, I freehanded like a little cardinal wearing like a scarf sitting on like a tree branch, because my aunt just like loves birds, and I thought that'd be cute. And then for my mom, I did like a large cupcake, like a coaster type thing, because she likes cupcakes. And they're cute, but you'll just have to take my word for it, I guess.
I like, it was a half memory in my brain of what punch needle was, and have Googled it, and it looks like lots of fun.
It is fun.
Yeah. That's great. I feel like it's like mini rug tufting. Is that accurate?
Yeah, that's basically what it is. And you can do large rugs. It just is a little bit more time consuming because obviously it's you're doing everything by hand, so it's like a lot.
Right. That's a lot of work.
Yeah.
Cool. That's awesome. Well, I'm glad you got to see family. That's always nice to do. And glad you're back. So we'll see you in this week, maybe.
Yeah.
All right. We have Arvia, James, and Norm are all next up on the list. And Arvia was the first with her camera on.
Damn, I should have known. Hey y'all. Okay, let me share my screen so I can show y'all. You see my screen?
Yep.
Okay. So the first thing that I worked on with Corey's help this week was I finally found some wood. I think I told y'all that last week. And I had this wood log that started off like this, very ugly and a mess. It's walnut, and Corey showed a few of us how to clean up the log on the CNC. And this is the face of the log without much. This is just fresh out of the CNC, and it's a really beautiful log. I have it right. Can y'all still see me? No?
Yeah.
Oh, okay. So this is the log. I took some of the bark off. I'm going to go and sand it some more. I'll probably put some short legs on it, I think, to make like a plant stand. It's really heavy. So I'm like, I feel like it can't be anything more than that, honestly. But I have two of these, and I can send folks the guy in Wallingford, his shop. It was really affordable. I got a lot of walnut for like $70. And he was really great. So that was the first project. Now the question is, where is my folder without showing y'all all of my stuff on my desktop? Okay, so the main project I worked on this week, well, this is the walnut, well, another piece of the walnut before being cleaned up. Me and Corey did that yesterday. I'll stop sharing my screen and I'll show y'all the beginnings of a sign I'm making for my nephew. Stop share. His name is Dylan, and I asked him what he wanted his sign to say. So it says Dylan's Place on it. This is the walnut. It's really, really nice. So this is the walnut with a layer of polyurethane on it, and done on the CNC machine. And the plan is, I don't know anymore, but the plan was, possibly still is, to fill the letters in with some epoxy, white epoxy. But if y'all see this piece in person, like the walnut is so beautiful. I kind of don't want to do that, but I'm going to ask him what he wants to do, and he'll probably tell me he wants a color in it. But yeah, he settled on Dylan's Place as a sign. The first option was Dylan's bed. We moved him past that because that was silly. We're like, let's get a little more creative. Yeah, I'm hoping he can keep that for a while. And those were the main things I did on the CNC this week.
Cool. It's great. Yeah, it was neat to play around with that. That was the advanced V-carve tool path, right? So it was two tools to cut it away. Most of it was with the 1/4 inch, and then we used a V-bit also.
Yes, it was a really good project. Oh yeah, and I made a Roku stand. I'm not gonna get that, but I've been 3D printing everything. I'm like, this is y'all show me how to use a 3D printer, and now I want to make everything. So I made a Roku stand for my TV to sit my Roku on under it. I picked up today.
There you go. That's great. Nice work. James, your camera's still on. So what have you been up to this week?
I have been playing with Fusion 360 a little bit still. I'm trying to work through this tutorial that you can make a stamp in Fusion 360 that you can then 3D print. It's like geared towards designing for 3D printing, which is pretty cool. I managed to get badged on the Shipoko, but I hadn't gotten the chance to come back in and actually CNC anything. But I mentioned last week that I've been hand carving these little wizard men.
Yeah.
And the wood that I'm carving that out of is just square like this. And you really need only a little triangle because the face is out of the just this corner. So I made this very silly jig by setting the table saw at 245-degree angles and then cutting a little slice down the middle so that I could put one of these in the bandsaw and cut it in half down the middle, which I thought was pretty cool. Kind of like the total opposite of CNC or 3D printing or anything like that. I also got a hook knife, which is kind of terrifying, for making spoons, for carving spoons or bowls or whatever. So yeah, that's what I've been playing with.
That's awesome. Yeah, I think I'm fascinated by the stuff that you're up to, and there is no problem that it is very different from where the thing is going.
Yeah, I did play with the Shipoko a bit, but I just didn't have the time to get back into the space. So this week I want to.
Yeah, well, and like 100%, it makes sense to, if there's ever a moment to be a homebody, this week is probably it, right? Like, and so hopefully we're all good. Norm, what's up? Are you around? What have you been up to this week?
Okay, am I sharing it?
You're not sharing your screen yet, but you could.
Well, let's see. Hang on. How about now?
Yeah, we've got it.
All right, so I was just fooling around with the Shipoko. I imported a picture of an island that I did a laser cut on, and tried to do some hand tracing of a path, but it was kind of difficult. And then I simplified it and just did a geometric kind of form, which was easier to do, and it's nice in its own way. But you can see that the actual, I cleaned up the vector thing to make this file separately. So I want to do two different ways of seeing what I could do with the island. The island in a laser cut, if I've got it up here someplace, it's awfully nice. Yeah, it's right here. It's a lot of detail. And so I just thought I would see, well, what does it look like when you use the router thing? And so I used a small bit, very small bit. And this one I used a thing called the texture approach, which turns out to be just enormously time consuming. It's like, it's as though you have a Dremel with a tiny bit and you're just dipping it down one by one. And it created something, but this went a lot faster. I mean, this went really, really fast. They're both rough there, but then I cleaned them up a bit with the Dremel and with sandpaper, and they're nicer. So, just experimenting with the Shipoko.
Yeah, that's really cool. I feel like you hit an important barrier on the Shipoko that the laser kind of doesn't have, where when you've got small features, the size of your end mill matters a lot. So if you have delicate, like imagine sort of stringy text or your trees that are very small relative to the island, like to draw in a tree, the smallest a tree could be would be like one stroke with that end mill, which if it's a 1/16 end mill, it needs to be at least a 1/16 of an inch wide, right? So you're sort of hitting that barrier,
right.
Which is interesting, and why usually over the years it has done for me is I start to choose my designs for the CNC strategically so that I'm avoiding that barrier, right? And so designs like the island are fantastic for the laser, may not translate themselves well, and like your sort of symbolic shape of the island is a great way to translate that and have a representative thing that might mean the same, but doesn't run up against that barrier. Can be a good way to work
I'm going to
around
do
it.
another version, probably with a bigger bit, of not quite the geometric one, but a simplified version, and then combine it with some scroll work so that it could be kind of a scroll rather than a picture of an island. It would just be a component of a scroll. But I haven't done that yet. I did have one question, which was in terms of ultimately getting ready for the Gerber and how to use VCarve. It said that there would be a link to use a makerspace version of VCarve. I downloaded VCarve, but I didn't see any link anywhere. I do see a box that asks for a link. But.
Right. And that is something that I need to close the loop with Lior on, because the version that I have, I think, is probably the version I'm not supposed to have, which is like the same one that they install on the machine at MakeHaven. And so I want to make sure that I'm not like, so that if we all have that, we're not eating up the licenses that they have. Because
there's no urgency. I just noticed that I couldn't do it, and I'm not trying to do it immediately, but at some point I probably would want to try it.
No, you're totally right. And absolutely, we need to get that buttoned up. We'll have it for sure. Definitely we'll have it for that week. But I'll try and get it sorted beforehand and let you know. But in a lot of ways, VCarve feels like the Carbide Create software. It's just got more options, and like their VCarve process is, I would say, better than the VCarve on Carbide Create. Carbide Creates is fine, but the VCarve one is their namesake toolpath. And there's lots of other good tricks. VCarve, I think, would do better at there's some color and detail in the picture of your island. You might do better with sort of making a 3-dimensional piece where the darkness maps to depth of your cut. Another thing, if you wanted to try it, other ideas I was thinking about is you cut it as a pocket, the island, but if you cut it as a raised section and a pocket around it, you might actually get a better resolve.
Yeah.
Because then you don't need the tool bit to cut out the trees. You're cutting the border outside the trees. So you'd get a little bit better detail of the whole island if you came at it sort of in the exact opposite way that you did, where the island is left and you've cut away the things around it.
Yeah, and the other thing is nothing stops me from using a Dremel afterwards to use the CNC to get it close and then do fine work with a very small Dremel.
Yep. Or the V-bit is really good too, because it changes. A V has different width as you go down. And so especially VCarve, but the Carbide Create will do it. It's just much slower at it. It will say, if you have a really fine point, it'll go from the very bottom of the V-bit. And if it's a wider detail, it goes from the top. And so it can sort of like choose the width that way. The VCarve way to generate that toolpath seems to be much faster than the Carbide Create way that it makes V tool bits. But they're both clever in using the geometry of a V-shaped bit to give you as much detail as you can get. So
thanks.
Yeah, no problem. And Steve, did you do anything fun this week?
Just a lot of housework, and I'm starting to harvest some pallet wood from a stack. Want to make some cabinet doors out of them.
That's exciting. That's lots of fun. Cool. All right, everybody. I think we did it. We went through show and tell for everybody who's here. And I'm real excited for us to hop into things and to make some more stuff this week. The sewable circuits will be a good time. The grab bags for these, we have all the stuff. It's all come in, and I'm going to go in tomorrow, like after school sometime, and get those together. It's going to be just like a fly in, put them into gift bags, and then fly out. If you're there before me, it's already on the foundation shelf in the back. And so you could totally go in and grab yourself a set of sequins, the battery pack, and then a conductive thread. But I'll be putting those into like gift bags. So it's easy to like, this is my bag. I can grab it and go away if you want to. And then you don't have to stick around and do it there. If you don't want to, you totally can stick around and help. I'll help. I'll be around on Thursday and Sunday per usual. And lots of fun and exciting things. So I hope that we have a good time. If you're starting to think about it, you can also look forward a little bit and think about what you'd want to do for integration week. It'll be just sort of all the guardrails are lifted. You can do whatever you want. It'd be cool if it integrated multiple sort of disciplines that we've talked about. That would be the one suggestion. But it might take a little bit to think about that idea. And then if you know you need to buy something or procure something, procurement always takes a little longer than expected. So if you wanted to buy something in advance, this could be the week to do it, just to sort of have it so you can hit the ground running next week. So that is the game plan. Tomorrow I'll be putting those gift bags of circuit stuff together, and I'll be around for a little bit, but I'll mostly be around on Thursday and Sunday to hang out and help people. So that's it. It's good to see everybody. Glad that we're back. It'll be fun to make things soon, and have a good night. See ya. Stay healthy.